we're going to do a video today on vertex form by completing the square day 2, where the number in front of x squared is not 1. Yesterday, we completed the square on things like x squared plus 12x plus, let's say, 10. And when we did that, we would pull the 10 away, and we worked with x squared plus 12x. Pulling the 10 away meant we just had to go ahead and work with the first part of the problem. Today, the first part, the a value, which would be in front of x squared, let's say it's not a 1. Let's say we put a 2 there. So that changes the problem. It changes a little bit how we approach it. We're still going to complete the square, but it is going to mean an adjustment. So let's just look at some problems. All right, we're still going to half it, then square it. That's still something that's going to happen. We're going to have vertex form. We're going to have parentheses squared plus a number at the end. And we're probably going to have that a value in the front, maybe a 2, maybe a negative. If there is a coefficient in front of x squared, it must be factored out before you can half it, then square it. So we are going to factor out a number. And then you must adjust for the factored term. Now, these next boxes, since we don't have an issued textbook, this would at least give you a resource, something you could look at, something that if you were completely lost and you're like, man, I just thought I knew what to do, this could actually give you some good information. So I did print that for you, but we're also going to have this video to use as a resource, so I'm going to go ahead and work one out. Actually, I'm going to work 3 out. All right, let's do number 1. The first thing I need you to do is I notice that there is a 2 in front of x squared. I can't just jump in and complete the square until I factor out the 2. I'm only going to work with the first 2 parts. My x term is going to end up being the term that I do half it, then square it. I don't need the plus 30, so that's going to be the part that's going to be pulled away. So I know I'm going to factor out the 2 because that's what it says I need to do. I need to get rid of the 2. I'm going to open parentheses. It's going to be big enough for 3 terms, and I'm pulling the plus 30 away. All right, so really it's like I'm dividing by 2, and I'm going to put what's left here, divide the middle by 2, and put what's left there. All right, so 2 cancels 2, and I have x squared. 12 divided by 2 gives me 6, so I'm going to end up with plus 6x in the middle. All right, now for the next few minutes, I only want to consider what's inside the parentheses. I'm going to complete the square inside the parentheses. So if I take half of 6, 3. So half of 6 is 3. 3 squared is 9. So I need to add the 9. Okay. Now, here is the adjustment we're going to have to make. What you have to remember is that if we just throw a number in, we have to adjust for it somewhere else. Typically, yesterday, if we added the number we needed, we subtracted it at the end. Well, I'm still going to do that in some sense, except if I go back and remember, that was really 2x squared. That was really what? 12x to begin with, which means 9 would actually really be like what? 18. Okay, so I really added an 18 to the problem. Notice I added a 9 in the parentheses, but it's really 9 times 2. I really added 18. That's the adjustment. So if I added 18 to the problem, then I'm going to come at the end and I'm going to subtract 18. Okay, subtracting 18. So if I added the 18 and subtracted the 18, then that would be basically like adding 0, and then plus 18 minus 18 would be adding 0, and I'd still have 2x squared plus 12x plus 30, which is back what the original problem said. Okay, so does everybody understand? Pause for just a second. I hope everybody understands. I did add 9 inside the parentheses, but I have to remember it's really 9 times 2, so I really added 18 overall. So I had to subtract 18 overall. All right, so that's the adjustment. So I don't really need, I just needed to work that out to show you why we ended up subtracting 18. From this point on, I will never really need to do anything else with the 2. So I'm going to carry it just like when we factored. Don't leave your baby at the mall. The parentheses now should be a perfect square, so that should factor x and x. What multiplies give 9, that has to be 6, is plus 3, And so that's going to be x plus 3 parentheses squared, have a 2 in the front. Okay? Now, the number at the end, plus 30 minus 18, plus 30 minus 18, I think turns out to be plus 12. So now, after all of that work, I now have my equation that's now been changed to vertex form. Okay? So this would be in the form, like 2 is like my A, 3 is like the H, 12 is like the K. We do know that the vertex form, I pull out the number closest to X, pull this out, this one comes out opposite the number, so negative 3. The number at the end is my Y value, and it comes out same as the number, so it's going to come out positive 12. So the vertex of the parabola that I have in the first example is negative 3, 12. That is what it looks like when you have a number in front. So we do have that extra step of factoring out the 2 and figuring out what the adjusted factor would be. All right, number 2. First thing I notice is not only do I have a 2, I also have a negative. So what I'm going to do this time is I'm going to think, well, I'm going to factor out negative 2 from the first 2 parts, and guess what I'm going to pull away from the problem? Yep, you guessed it. I'm going to end up pulling minus 40 away from the problem. So I'm going to begin with negative 2. I'm going to open up parentheses big enough for 3 parts, and then I'm going to pull away minus 40 at the end. Minus 40 does not get factored. So it's like I'm dividing by negative 2 and divide by negative 2. Now remember, if you divide by negative, it really changes the signs. So negative 2 divided by negative 2 is positive x squared. Negative 16 divided by negative 2 is positive 8x. Okay? All right, negative 8x. Now I'm going to do half the middle term and square it. Half of 8 is 4. 4 squared is 16. So I'm going to add 16 to the parentheses. Adding 16 to the parentheses, I have to imagine, what did I really add overall? Well, I hope that you don't have to write this each time, but if you could imagine, you know, negative 2 times that, negative 2 times the middle. Okay, I really added, negative 2 times 16 is really negative 32. I really ended up adding negative 32. I really ended up adding negative 32. Does everybody see that? Okay. Now, we have to add something at the end that's going to offset adding a negative 32. Now, that's the first time we ever added a negative. So hopefully somebody's thinking, oh, well, what if we added positive 32? Well, positive 32 and negative 32 would add up to be 0. And then the problem, negative 2x squared minus 6x minus 40, would be exactly like the original problem. So I hope everybody knows that we really added negative 2 times 16, we really added negative 32. So we're actually going to have to add 32. So I'm going to come out here and add 32. That is probably the most confusing it will ever be. From this point on, I don't need the negative 2 for anything else. Just carry it along. 2 sets of parentheses. These 2 are going to subtract or add, in this case, to be positive 8. X and X. What multiplies gives 16, that adds to be 8. It's going to be plus 4, plus 4. So I have negative 2, x plus 4 parentheses squared plus 8. My vertex, okay, is at negative 4 and positive 8. The inside number comes out opposite, and that's the number close with x, so that is my x coordinate. The number at the end comes down same as the number, and that's my y coordinate. So my vertex is at negative 4, positive 8. All right. The second example is the trickiest example, because a lot of people get kind of bogged down on the negative 32 part. Hopefully you do understand why we had to add positive 32, because that was different. Number 3, it says look closely. First thing I hope that jumps out at everybody is I don't have an x right here in the very end. So when I really look at this closely, I cannot complete the square. And actually, the plus 4 is going to be the number at the end, and I can't complete the square. And when I really consider it, you know what? I could really put x squared like that, but what number is being added to x? Well, there is no square to complete, so it's just like adding 0. Okay? I don't have a middle term. There's nothing else I need to do except recognize, hey, This is really just a modified easy function that has 0 as the x and positive 4 as the y. Vertex is 0 and 4. You cannot complete the square. No, complete the square. You can't because you do not have an x term. Okay? If you don't have an x term, you can't complete the square. Right, so that's our quick, brief lesson on day 2, finding the vertex form when you have a number in front of your x square.